All right, hey, thank you for Kat for starting our discussion board off. She wants to talk about the solution to cosine squared equal 1/2. And we need to start off by taking the square root of both sides because that'll get rid of the square, right? That's why we're doing it. So we get cosine x equals, all right, now here's where a common mistake happens. Everybody wants to always forget to put plus or minus. So we always have to put plus or minus when we take both the square root of both sides of an equation. So plus or minus, how can we simplify this? The square root of 1 is just 1, and then the square root of 2. If we rationalize this, multiply by square root 2 over square root 2, we get plus or minus square root 2 over 2. Okay, so what we're trying to find out is where is cosine equal to plus or minus square root 2 over 2. Now, let's get to answering just within 0 to 2 pi. All right, so within 0 to 2 pi, that happens 4 different places, right? We have pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Now what about all of the exact solutions, right? Because there's an infinite amount of solutions because of all the coterminal angles. So we have to think about this. This one's kind of an interesting case. If I were to draw the picture out for us, let's see if this is on the camera here. Pi over 4 is smack dab in the middle here, right? 3 pi over 4 is smack dab in the middle here. 5 pi over 4 is right in the middle here. And 7 pi over 4 is right in the middle here. Okay, do you notice a relationship between these? So what would I have to add on to pi over 4 to get to 3 pi over 4? And then hint, it'll be the same value if we add it to 3 pi over 4, we'll get to 5 pi over 4. And if we add it to 5 pi over 4, we'll get to 7 pi over 4. And if we add it to 7 pi over 4, we'll get to a coterminal angle with pi over 4. What is that value? If you're thinking these look like right angles, you're right. Those are 90-degree angles that are pi over 2 radians. So what we can do is say that x is equal to pi over 4 plus pi over 2k, which just means we can add any multiple of pi over 2 to pi over 4 to get all of the infinite solutions that exist for this. Okay, so you can plug in whatever integers that you want for k. Hopefully that helps you, and I'll see you for the next one.